So, good morning. In the previous classes, we discussed about the forced response of series RLC circuit and parallel RLC circuit, right? So, we also seen some of the examples, and we also seen one application of this second order circuit. Okay. So now we will move on to generalized second order circuits. So these circuits, so neither in series RLC form or nor in parallel RLC form. So these are the generalized or the general second order circuits. General second order circuits. Right. So here, so let's assume that, so consider one example here. Say it is off farad and its voltage is V. So this is 2 ohm and this particular switch is closed at t equal to 0, and this is 1 Henry.
Switch is closed or open?
Switch is closed. Yeah, closed at t equal to 0. So this is 4 ohm and this is 12 volts. Right. So if you notice that, right, so when this switch is closed at t equal to 0, so this circuit will be, so neither in series or series RLC circuit, so nor in parallel RLC circuit, right? So what we have to do is, so for this particular kind of problems, right? So you may think that, so we can use this one, for example, some may think that, right, so here we can convert this into its equivalent current source. Is it possible?
No, sir.
No, sir.
No,
No,
right.
sir.
So because of this inductance, right? So when it is a AC source, for example, if you assume this is a AC source, so then it is possible. Okay. Right. If this inductor is not present, so in that case, you may convert this into its equivalent current source. Right. So how to proceed with this kind of problems is, so we need to formulate the differential equation, or in other words, we need to formulate the characteristic equation of this circuit. So from the characteristic equations, you need to find out the roots. So from the roots, we have to estimate the overall solution for the differential equation, right? So that is the procedure. So no need to calculate. So here, so alpha calculations, omega naught calculations, alpha greater than omega naught over temperature response, those things will not work here. So those are only for series RLC and parallel RLC circuits. Okay. Right. So first thing, so we need to find the initial conditions, right? So what is V of 0? And assume this is the current I. For this circuit, you need to find V of t and I of t for t greater than or equal to 0. So what is V of 0 for this particular circuit?
12 volts.
12 volts.
So 12 volts, right? So this is short circuited and this is open circuited. So therefore it is 12 volts. So what is I of 0?
0 ampere.
So this is open circuited and this is also open. The switch is also open. Right. So this switch is open. So this is open. So there is no current through this inductor because it's open. Right. So therefore this is 0 ampere. right? So we require some initial conditions. So you may require dv of 0 by dt. So you may require dv of 0 by dt. So how to find dv of 0 by dt in this particular circuit?
Sir, apply KCL at
So this will be the circuit, right? Okay. So what is dv of 0 by dt? So what it will be? It is equal to IC of 0 by C, right? Agree?
Sir,
Yes.
2 ohm resistor is also there, na?
That is open, no? This one.
Sir, is this we are talking about, sir, t less than 0?
Yeah, t less than 0. No. Wait. Oh, this 2 ohm resistor is there. Sorry. Which is right. This will be circuit for t equal to 0, right? Okay. So this is 2 ohm. So now tell me what is the current through the inductor. So how to calculate? So this is the capacitor current IC, right? So how to calculate IC? How to do this?
Node
How
voltage.
to- So here, if you assume this is ground, right? So this voltage is V, right?
Yeah.
Okay. If this voltage is V, so what is this current? So this is if you apply KCL at node V. So this is incoming current, right? So what is its value? So it will
Minus
be I of 0, right? Agree? So which is I of 0, incoming current, right? So this is also if you assume that this is outgoing current, so which is equal to V by 2.
plus
Agree?
IC.
So that means V of 0 by 2 plus, what is the other value? Plus IC of 0. Okay. So what is IC of 0? So what is I of 0? I of 0
into
is
dv by
0,
0
right?
by dt.
So it will be minus 6. Agree?
Yes, sir.
Okay. So now what is this one? IC of 0 by C, right? So what is IC of 0? Minus 6. So what is the value of C?
1 by 2.
1 by 2. So that means this is minus 12 volts per second. Understood? Understood?
Yes, sir.
Okay. Clear? So we found some initial conditions, right? So what is the next step? So what is the next step for t greater than or equal to 0? The circuit will be like this. So this is what is this? Well, half farad. So this is a 2 ohm, right? What is this inductor? How much?
1 Henry, sir.
1 Henry. And this resistor, this is 12 volts. And this resistor value?
4 ohms, sir.
4 ohm. Okay. So this is the circuit for t greater than 0. So you've observed that. So this is neither a series RLC circuit nor a parallel RLC circuit. Okay. Right. So this is voltage across capacitor V and the inductor
Sir,
current. Yeah. Yes.
Sir, in order to calculate, sir, initial conditions, sir, V0, I0, sir,
Yes.
sir, in this case, in general second order circuit, sir, we can't apply that concept that I0 minus is equal to I0 and V0 minus is equal to V0, sir.
What you're saying? I0 minus?
Sir, means, sir, I0 minus, like, inductor does not allow
I
change
of
in
0
current.
minus, yeah, same thing only we applied, right?
Yes, sir.
This same thing only we applied, right? So this how we achieved this one? We have 0. So initially we have 0 minus is 12 volts and I have 0 minus is 12 volts, right? So this is how we achieved these two. So this property will never change. Okay. So whatever the circuit,
Okay,
so this
sir.
property will never change. Inductor current and capacitor voltage. Right. This is the circuit,
Okay,
right?
sir.
So this is I. Okay. So now, so what we have to do is, so here the question may be asked to find out what is V of t, right? So what is V of t? See, in one of the class we discussed that. So this is equal to, so this is equal to, there are two parts with this. So one is the steady state part of t plus transient part of t. V transient of t. Clear? So we have two parts, right? So what is its steady state part? So which is equal to V infinite, right? So what is V infinite?
12 volts.
What is V
Correct.
infinite? Is it 12
4
volts?
volt. 4 volt.
4 volt.
So voltage,
volts,
this
sir.
is voltage across this 2 ohm resistor, right? Agree? So this will be the
Yes.
voltage across this 2 ohm resistor. What is the voltage across this 2 ohm resistor? Which is equal to 2 by
4 volt.
4 plus 2 into 12. So how much it is?
4
6 volts? 4 volts. 4
4
volts,
volt.
right? Yeah. So V infinite is 4 volts. Right. So how to find the transient? How to find the transient? So what are the reason for transients? What are the reason for transients? So this one is due to initial voltage across capacitor or initial current through the inductor, right? Agree?
Yes, sir.
Yes,
Right.
sir.
So here, so how to calculate this one? So what we have to do is, so we need to turn off all the sources, right? So we need to turn off all the sources. If it is a voltage source, we need to short circuit the voltage source. If it is a current source, so we need to short circuit the open circuit the current source, right? So you have one voltage source is there, you just short circuit that. So this off farad, so this 2 ohm, right? So from this, so we can calculate its transient response. We can calculate a transient response. See here with 12 volts source, so what kind of response you will get, so that we obtained, right? So with this, so you can obtain its transient response. Understood? Understood. So what we studied, the transient response is due to the initial voltage across the capacitor and the initial current through the inductor, right? So how to explicitly, or how to separate the transient part? So for that we need to remove the sources. If it is a voltage source, you just short circuit the voltage source. If it is a current source, you need to open circuit the current source. All right. So now, so this is the circuit. So from this circuit, so we need to find its transient response, right? And we need to add its steady state response so that the overall solution can be obtained. Okay. If this is the circuit, right? If this is the circuit, so how to proceed this one? So how to proceed with this?
Sir, parallel RLC, sir.
What you're saying?
Parallel RLC.
This is not a parallel RLC, right? So we have this additional resistor is connected here.
Yes, sir. We can take rent resistance and take.
How to take that net resistance? You cannot avoid that, right? Okay. You cannot do that. So why? Because this is associated with the inductor. All right. So let us assume that. So what we have to do is that. So we need to obtain a differential equation. We need to obtain a differential equation. So with this circuit. In previous classes or in previous we studied, right, when you're studying the series RLC and parallel RLC sets, how to obtain the differential equations. So from the differential equations, how to obtain the characteristic equations that we studied, right? So we use that same methodology here, right? So we are interested right now, we are interested in voltage V, right? So let's assume that this is voltage V, so therefore this will be V. All right. So this is current I. If this is current I, so apply KCL at node V. So what it gives? So KCL at node V. So this is incoming current I plus, so assume this is outgoing current. So this is also outgoing current. So what is that outgoing current equal to? So what is that outgoing current?
V by 2,
Sir, V by 2 plus
By 2
IC.
plus IC.
P by 2 plus
IC.
or half
IC.
into
What is
dV
IC?
by dt.
Half
into
into
dV by dt.
C into
dV
dV by
by
dt.
by
dt.
dt.
dV by dt.
Okay. So keep this aside. So we observe that this is with I and V. So you have one
Sir?
side I term is there and V term there. So what we have to do is when you are bringing that differential equation, it should be either in V or it should be either in I. Understood? Clear?
Sir?
Yes?
Sir, that should be minus half V by dt or plus. Sir.
Why minus of? If this is the current direction, right? This is plus of only.
Okay, sir.
So this is the capacitor current. Okay. So this is the formula 1 by C into dV by dt.
Sir, it is flowing from plus to minus now. Sir.
No, 1 by C into d. What you're saying?
It is flowing from plus to minus, positive to negative.
No, no, if the capacitor based on the incoming current to the capacitor, we'll decide the sign. Okay.
Okay.
Right. So that means charging the capacitor. See here, this is the thing, right? If the capacitor is outgoing, current is outgoing, that means the capacitor is discharging. Okay. If this capacitor is incoming, the current is incoming, so that means the capacitor is charging. So when you're giving the notations, so we always follow charging. If it is a battery or a capacitor, we always follow the charging current or the charging current of the battery or charging current of the capacitor, right? Okay. So how to eliminate this current I in this expression? How to
Sir,
eliminate
V
this
equal
current
to
I?
4I plus dI by dt.
For
Then first differentiate the
4I plus
equation.
dI by dt.
Differentiate.
what you will get if you differentiate this one? Di by dt term will come, right? Okay. So instead of making it complex, so you can, this is, right, if you assume this current is I, this is the I current, right? Okay. So if we apply KVL at loop 1, so what it will give? KVL at loop 1. This is the one, right? So what it will give?
4I.
4 into I plus
1 into dI by
1 into di by dt plus, so what
I
is the current
minus
that flows
IC.
through this two? For example, this is another current, some IC. This is
IC.
IC.
I minus IC.
I minus IC. Again, you are creating another unknown variable, right? So what is ultimately you need to calculate the voltage across this one, right? What is the voltage across this one?
VC.
So it is exactly equal to voltage across the capacitor, right?
Yeah.
Agree with that? So both are parallel. So 2 ohm resistor and that half farad capacitor. So both are parallel. So we can safely write. So this is equal to 0. Understood in this particular problem? Clear?
Yes, sir.
Right. So now, so what we obtained here. So this is another equation. So V equal to, or in other words, what we are interested, we need to bring these things into V square form, right? So here I value is known to you. Okay. So substitute here. So 4 into, what is I here? So 4 into V by 2 plus of dV by dt plus, what is di by dt here? What is di by dt? What is di by dt?
Derivative of
I, right?
1 by 2 into dv by dt plus 1 by 2 into d square v by dt.
It is d by dt of this entire thing, v by 2 plus 1 by 2 dv by dt plus v equal to 0. Understood? Right. So what is this expression? So 4 into v by 2, right, plus 2 into dv by dt plus 1 by 2 into dv by dt. What else you have? 1 by 2 into d square v by dt square plus v equal to 0. Is this correct?
Yes, sir.
Okay. Right. So here, so we require, so multiply this one with 2 so that you'll get d square v by dt square. Right. So what you will get, d square v by dt square. We are multiplying with 2, right? So that means 2v here and another v. So how many v's? This is multiplying with 2, right? So 2v plus 2v, 6v.
yes, sir.
What else you have?
dV by
So dv terms, right? So this is 4 dv. So this is 1 dv, 5 dv by dt. Is this correct?
correct, sir.
Yes, sir.
Sir, 3V will come now.
Why 3v? It is 2, right? We are multiplying with 2. So that means it is 4 dv by dt and it's 1 by 2. If you multiply with 2, so dv. Why we are multiplying with 2? Simple thing. So why we are multiplying with 2?
Coefficient of d square
So
by
this
dt
one, this
square.
coefficient is there, right? We need to bring this one into d square v by dt square form without any multiplier for that. Okay, so that's why we are multiplying with 2. Okay. Is this clear?
Yes,
So
sir.
this will give d square v by dt square. So 5 dv by dt plus 6v equal to 0. Right. So what is its characteristic equation? So it will be s square. So 5s plus 6 equal to 0. So that is its characteristic equation, right? Everyone agree?
Yes, sir.
Okay. So what are the roots s1, s2?
-3, -2.
-3 and -2.
-2.
Right. If roots are -3 and -2, so that means roots are negative and integer. So what kind of solution we can expect? So it will be
4 and
a1 into e to the power of -3t, right? a2 into e to the power of -2t. Agree?
Sir.
So this is the solution we can expect, right?
Yes, sir.
Right. So now tell me, what is the overall solution v of t? So v of t, overall solution. So this is the one. V steady state of t plus V transient of t. So what is V steady state of t? So that is 4 volts plus what is V transient of t? So A1 e to the power of -3t plus A2 e to the power of -2t. Understood?
Sir,
Yes.
so if it's a general second order circuit and we get a differential equation and the roots of the characteristic equation are integer and negative, then that means this will be the solution.
Yeah, this is the solution, right?
Okay.
We
Got it,
discussed
sir.
now if this is what kind of case it will be. If roots are negative, so this one, right? If the roots are equal, so S1 equal to S1, what kind of solution we can expect? So A1 plus A2t into e to the power of minus S1t, or minus not minus, so S1t you will get, right? That is the solution you will get, right?
Yes, sir.
Okay. If roots are complex, so what kind of solution you will get? So we have that A1 into e to the power of minus, right? That solution, you will get that
Yes, sir.
solution, right?
Yes,
Cos
sir.
omega
Okay.
dt and sin omega dt, that kind of solution you will get. Okay. So now, so you have two initial conditions, V of 0 and dV of 0 by dt. So V of 0 is 12 volts. I think this is minus 12 volts, not volts per second. So what is the first one? I think 4 plus A1 plus A2, which is equal to 12. Is this correct? So that means A1 plus A2, so which is equal to 8. So what is the second one? Minus 3 A1 minus 2 A2, so which is equal to minus 12. So that means 3A1 plus 2A2 equal to 12. So what is A1 and A2? Just correct me if I'm wrong. Am I correct?
A1 is minus 4, A2 is 12.
A1 is minus
Yes, sir.
4, A2 is 12.
Uh,
Okay. Understood. So now what is the overall solution V of t? 4 plus, what is A1?
Minus 4, sir.
Minus 4. Minus 4.
E power minus
We will
3t.
start with plus word. Just a second. Minus 4 e to the power of minus 3t plus 12 into e to the power of minus 2t. Is this correct? Is this correct?
Yes, sir. Yes, sir.
Okay.
Yes,
So
sir.
this is the solution for V of t. So another one they asked, right? What is I of t? What is I of t? Anyone answer this? What is I of t? How to calculate I of t?
sir, from
We got
equation
two
1.
equations. Yes.
From equation 1.
Equation 1 we have this, right? I equal to V by 2 plus 1 by 2 into, so this one.
Yes, sir.
Yes, sir.
Okay. So what is that equation? I equal to V by 2. What is the one? What is the next? V by 2
1 by 2 dv by dt.
of dV by dt. So do that and find out I of t.
Sir,
Yes.
Sir, here steady state current will also add now.
Hmm.
So because this is transient only.
One second. What you're saying?
Sir, in current expression, sir, I infinity will be also added now. Because this is V by 2 plus half dV by dt is only denotes the transient, sir, current.
No, this VIB is already we included here, right? See here, this is overall solution only, right?
Okay, sir.
Mm.
Okay, sir.
Sir,
Yes.
in final solution 2 is present means I infinity is 2, sir.
No, I infinity is 2 only.
Yes, sir.
What is the final solution you got? V by 2.
So 2 minus
Yeah.
6 e raised to minus 2t plus 4 into e raised to minus 3t.
Minus 3t.
Uh,
So this 2 is included, right? I think what is I infinite? I infinite.
Two
What
only,
is I
sir.
infinite? 2 only,
Two.
right? So that is,
Two only,
that is
sir.
included. Okay. So why we are using this one? Thing is that even though the source is present here, okay, even though the source is present here, so this will equation will not alter, right? This equation will not alter. So there is no change in this equation if you observe that. So why? Because we are calculating the this current only, right? Right. So therefore, so there is no change in the equation. So this is how to calculate for the generalized cases. Okay. So for generalized things. So we'll try to solve one more problem. So this 20 U of t 1 ohm. So this half farad VC1 and this is VC2 and this is 1 ohm and this is 1/3 farad. So for this calculate so VC1 of t, VC2 of t and V0 of t. So this is V0 voltage across that 1 ohm resistor. So in between the two capacitors, so that is V0 for t greater than or equal to 0. Right. Okay. So how to proceed with this? If you observe that there is no inductor here in this circuit, there is no inductor here. You have only two capacitors. So, but later we'll find that, so this is also belongs to a second order circuit. So this is also belongs to a second order circuit. So in earlier, one of the class, we discussed that if you have two different kind of energy storage elements like capacitor and inductor, so then you have second order circuit, right? So here this is some special case, even though you have two different, you have only one capacitor, means two capacitors are there, so no inductor is there. So that means only one type of energy storage element is there. Still it is a second order circuit. So how exact it will be, so that we are going to find. Okay. So just for simplicity, I have written V1 here and V2 here. V1, V2, right. So here, so what is V initial conditions? You have two initial conditions, right? You have two capacitors. So what is V of 0 and what is V2 of 0?
0.
So 20 U of t, right? So that means the circuit will be like this. So that is short circuited. So this is 1 ohm here, 1 ohm here. This is V1, V2. So this is half farad and this is 1/3 farad. Right. So this is V0. All right. Okay. So what is V1 of 0? So there is no
0.
source here. So this is 0 volts and this is 0 volts. Okay. So what you understood that, so you need to bring the differential equations either in V1 form or V2 form, right? If you observe that, we need to calculate this V0. So what is V0 here? What is V0? So it will be V1 minus V2,
Yes,
right?
yes, sir.
Okay. So here, so what we have to do is, so we need to calculate V1, okay? Sorry. So we need to calculate V1, right? After that, we need to calculate V2. So from that, so you need to obtain V0, right? So how exactly we need to do, so that we'll find out. So what is two initial conditions you require, right? So dV1 of 0 by dt and dV2 of 0 by dt. So how to find this first initial condition? So how to find this first initial condition?
Current.
Yes. So here now this voltage is present, right? So when you're finding that, so this voltage is present, this is for t greater than or equal to 0. So to find out this one, so this voltage source is present, right? So now tell me, so how to
KVA.
do that?
KCL at node. Upper node.
KCL at, so this voltage will be, if you assume that this is ground, right? So this voltage will be V1, agree? And this will be V2. So KCL at V1, so what it gives? KCL at V1. So if you assume this current is I1, right, and this current is I2. Okay. So what it gives? KCL at node 1, loop 1.
20 minus V1 by 1 is equals
20
to minus
minus
V1
V1
upon 1.
upon 1 equal to
V1 minus V2 upon 1
V1 minus V2 upon 1.
plus half into dV1 by dt.
This is only, right?
The
Plus
capacitor also is
IC,
there.
sir.
Na?
IC1, sir. Sir, IC1.
What is IC1?
Half into dV1 by dt.
No, honestly, we are confusing. Wait just a second. So this is the current I1, right? Okay.
Yes, sir.
This is the current I1. So can we convert this into a current source? Can we convert this into a current source?
Yes, sir.
Yes, sir.
Okay. So in that case, so what you will get?
20 amperes.
20 ampere.
So it will be 20 amperes. So this will be the circuit, right? So this voltage is V. All right. Unnecessarily we are confusing. Just a second. So this is, what is the current this flowing through this capacitor? What is the current that flowing through this capacitor?
1 by 2 into dV1
So
by
that is I1 minus I2, right? So what is I1 minus I2? If you know the
By
voltage,
2 into
it is C
dV1 by
into
dt.
dV1 by dt, right? Agree? So this is one equation, right? So now you can apply KVL in loop 1, right? So what you will get if you apply KVL in loop 1? So this is I1 current, right? And this is I2 current. So what you will get? So 20
20 is equal to I1 plus V1.
1 into I1 plus V1, right? So this is another equation. Okay. Similarly, KVL at loop 2. So what you can get? KVL at loop 2. So what you will get? KVL at loop 2.
Minus V1
Yeah, minus V1.
plus
So why
V0.
minus V1? This current is flowing from minus to plus, right? So minus V1 plus 1 into I2, right?
Yes,
Plus
sir.
V2 equal to 0. Understood? So this is the third equation. So what ultimately we need to find out? So we need to find, so dV1 of 0 by dt, right? So we need to find, so dV1 of 0 by dt. So how to find the dV1 of 0 by dt? So here this expression, right? So with this expression, can you find that? Is it possible?
Yes, sir.
How to do
Yes,
that?
sir.
Sir, I1 we can write, sir, C dV1 by
So
dt.
we can subtract I1 minus I2. There.
You can subtract.
In second and third equation, subtracting
Yes, sir.
Yeah. Second and third, if you subtract that, what you will get?
I1 minus I2, sir.
2 minus 1. Second and third, what you will get if you subtract second and third? So that means if you subtract 3 and 2, so this is the one you're trying to say. Okay. So what you will get?
V1 minus V2 is equal
2V1 minus V2. Yeah, tell me.
Sir, again two variables will come, sir.
Two variables will come, right?
Yes, sir.
Sir,
So we'll
but at,
substitute
but at
I1, sir, with
t equal to
half
0,
dV1
V1 and V2 are 0 now, sir.
At t equal to 0,
V1 and V2 are 0. So subtracting those, we will get I1 minus I2 now.
so what you will get I2 value then?
I2 value is 0, sir.
I2 value is 0. So why I2 value is 0?
Because at t equals to 0,
This is the t equal to 0. So from this, I2 value is 0, right? So here third equation. So we have minus V1 of 0 plus I2 plus V2 of 0, so which is equal to 0. So from this I2 equal to 0.
Sir, that is I2 of 0, sir. Not I2
Yeah,
of
I2
T.
of 0. Yeah, of course. Zero, right?
Yes, sir.
Yes. Right. So what is the other way to obtain this one?
I1 of 0 equals to 20.
I1 of,
0 equals to 20.
so from this,
Yes,
you're
sir.
saying, right? So we have 20 equal to I1 of 0 plus V1 of 0, right? So from this I1 of 0 is 20.
Yes, sir. So I1 minus I2 20 equals to C into dV1 by dt.
So we have that original C into dV1 by, right? So dt, so which is equal to I1 minus I2. That means
Yes,
which is
sir.
equal to I1 of 0 minus I2 of 0, right? So from this, what is C dV1 of 0 by dt?
40, sir.
40. I1 of 0,
20 minus 0 into 2. 20 into 2,
40
40.
minus 0,
C equals to 1 by 2, sir.
C equal to 1 by 2. It's 40.
40. Yes, sir.
Is this correct?
Yes, sir.
Yes, sir.
Okay. So what is the next step? So what is the next thing we need to find?
DV2
DV2.
also.
Loop method for dV2.
So we know that, so V1 of 0 minus, okay, if you apply that, this one, right? So what is V0 of 0? What is V0 of 0 plus? What you will get? So V0 of 0. What is V0 of 0? What is V0 of plus? What is its value?
20, sir.
So
20.
0,
20?
because
It is
I2 of
0
0 is
only, right?
0.
So it will be V1 of 0 minus V2 of 0. So that is 0,
0, sir.
right? Okay. If we apply KVL at that node V, right? So for example, if you apply KVL at node V, so what you will get? So V1 minus 20 by 1, right? 1 ampere plus what is the next term? What is the next current? If you apply
Of
KVL here,
dV1 by dt.
Sir, where is V,
half
sir?
into dV1 by dt plus what is the next
Minus
term? So 1 by 3 into,
V.
so what
Sir,
is the
where
other?
is V, sir? Sir, V, sir.
V1. Okay. Just a lot of confusing for
It
me.
is
This
V1.
is V1, right?
Yes, sir.
Yes, sir. So then 20 minus V1 will be now.
No, V1 minus 20 only, right? By 1
Correct, sir.
plus 1 by 2 into dV1 by dt.
It's V1 minus V2.
So what else you have?
V1 minus V2, sir.
V1 minus V2. V1 minus V2, so which is equal to 0. Right. So now at t equal to 0, so V1 of 0 minus 20 plus 1 by 2 dV1 of 0 by dt. So what is V1 of 0?
Sir, we
Plus
have all the
V-
values, sir.
Hmm?
We have
We
all the
have all
values,
the
right, sir?
values, sir.
So what is dv1 of 0 by dt?
That is 40. We found
40,
out
sir.
already.
We already calculated this.
Yes. Left hand.
It is,
Yes, sir. We should calculate for dv2 of 0 by dt, sir.
okay. We need to calculate for that. Okay.
Sir,
Yes.
we find the relation v0 is equals to v1 minus v2. Then differentiate this one with respect to t.
No, sir. We should not do that.
Is equal to C into dv2 by dt.
Sir, applying loop method for second one, we can get dv2
Yeah.
of 0
Applying
by
loop
dt.
method for second one, what you will get? What you will get if you apply loop method for second one?
V1
if you
minus
apply
V2
KVL
equal
at
to I2, sir.
KVL or sorry KCL at node 2 or node V2. So what you will get?
There is only one current, sir.
Only
For
one current flowing now, sir.
only one current is there, sir.
Only
for
one
node
current
2.
is flowing, right? But that current can be written, right? So I think we already calculate I2 of 0. We already calculated I2 of 0, right?
Yes,
What is
sir.
I2 of 0? That is
0.
0, right?
Sir. Hmm.
So now you tell me, so this voltage across that capacitor, so that means 1 by 3. So I2 of 0, which is equal to 1 by 3. So dv of dv2 of 2 by dt. So both are same.
Yes, sir.
Both are same, right?
Yes, sir.
This will be dv2 of 0 by
dv2 of
so
0 by dt
dt,
equals
so
to
which is
0.
equal to 0.
Yes, sir.
Is this correct?
Yes, sir.
Okay. So at last we find all the relations. Unnecessarily we are confusing, right? Instead of hit and trial. So what we have to straight away, so no need of all these things. Straight away apply KCL at node V1, right?
Yes,
Okay.
sir.
So that gives the answer straight away. So apply KCL at node V1. So that what it will give. So V1 by 20. Okay. Plus 1 by 2 into. So this is the one that will gives. So this itself is enough to calculate. So dv1 of 0 by dt. So this itself is enough to calculate this one, right? Okay. So we have this additional equations. So from that additional equation, you need to calculate I2 of 0. So from that, you can calculate dv2 of 0 by dv2 of 0 by dt, which is equal to 0. So once this is done, so now you understood, right? So no need of doing this much lengthy exercise. Straight away use this one, okay? And after that this one, and this one. So these three steps are enough to calculate these things. So now once it is you're done with that one, right? So we need to find v1 of t first. So v1 of t first. So we assume that v1 of t equal to v1 of t steady state and v1 of t transient of t. So what is v1 of t steady state value? So what is its steady state value? v1 of t steady state value.
20.
20 volts, right?
Volts, sir.
Yes, sir.
The capacitor steady state value is 20 volts. So V transient of T, so we need to develop the equivalent circuit. So by removing all the sources, so this is 1 by 3 here, 1 by 2 here. So this is 1 ohm and this is 1 ohm. So this is V1. Right. So we have well-known equation. So of d v1 by dt, so which is equal to I1 minus I2. So if you assume this current is I1 and this current is I2. We all agree with this, right?
Yes, sir.
Okay, and if you apply, so this is KCL at no, not KCL or KVL. This is one equation, right? So if you apply KVL in loop 1, so what you will get if you apply KVL in loop 1? So will it be I1 plus V1 equal to 0?
Yes, sir.
I1 plus V1 equal to 0. Similarly, loop 2. So what is loop 2? Minus V1 plus
Plus
I2,
V2.
1 into I2, right? So plus V2, so which is equal to 0.
Sir.
Okay, so we have this I2 here, right? So I2 equal to V2 minus V1. So I2 equal to, so V2 minus V1. So from this, we need to bring a differential equation.
I2 is equal to V1 minus V2.
V1 minus V2. Yeah, V1 minus V2. Somehow we need to bring the differential equations. And also there is another one. So this I2 is equal to, what is the value of I2? So this is the capacitor current, right? So 1 by 3
1 by 3 dV2 by
dV2
dVt.
by dt.
dV2 by dt.
So by using all these relations, so we need to develop a differential equations. So which is it explicitly contains only V1 terms, right? So now this voltage will be V1. So now if we apply KVL at V1, this node KVL, so KCL at node V1. So what you will get? So what is the first term? We assume that voltage is V1, right? So V1 by 1 plus V1 by 1 plus 1 by 2 into dV1 by dt, right? So what is the next one? So what is this one? This is the current I2, right? So this is current I2, so which is equal to 1 by 3 dV2 by dt. Agree?
Yes, sir.
Okay. We just applied I2. This is I2, right? So but I2 is equal to 1 by 3 dV2 by dt, which is equal to 0. All right. So this contains V1 terms and this V2 terms, right? Somehow we need to write, or somehow we need to eliminate this V2 term. So how to eliminate this V2 term? So how to eliminate this V2 term?
Sir, I2 equals to I1 minus 1 by 2 into dV1 by dt.
I2 equal to
Minus V1 minus 1 by 2 into dV1 by dt.
this is the one.
Sir, in I1 minus I2 equals to 1 by 2 into dV1 by dt. We can place
I1
I1
minus
as minus
I2.
V1. Sir, we can place I1 value as minus V1 in first equation, sir. 1 by 2 into dV1 by dt equals to I1 minus I2.
I1 minus I2 as, how to write this one?
1 by 2 into dV1 by dt, sir.
1 by 2 into dV1 by
dV1 by
dt.
I1 equals to minus V1 now, sir.
Yeah, I1 equal to minus V1. Yeah, correct.
So we directly can write that value now, sir. I2 value.
I think again we'll get the same.
Again, it will
equation.
comes in V2 terms only, right?
Why did you short circuit the source for T greater than 0?
Yes.
Why did you short circuit the source
We
for
already
T greater
discussed,
than
no,
0?
we are only finding out the transient response. okay, by short circuiting the source. Steady state
Okay.
response is already calculated here. So just we are adding, we are separating the terms with source and without source. Okay. Steady state response is with source and transient response is without source. So one is with decaying with time. So we are finding out by using its initial conditions.
Sir,
So
now
any idea
V1.
here how to
Yes,
So
sir.
obtain this?
differentiating I2 equals to V1 minus V2, sir.
Differentiating
I2 equals to V1 minus V2.
Sir, we can substitute V1 equal to V2 plus I2, sir.
you can
And
substitute
I2 we have in terms of V2, no, sir.
Sir.
I
But
do in terms-
we want the equation in V1 now.
V1 equal to V2 plus I2, sir. Substitute.
So what is I1 value? What is I1 value? So I1 is minus V1, right? Okay. So this can be written in another way, like so this V1 plus 1 by 2 into dV1 by dt, right? So what is the next term? So will it be V1 minus V2 equal to 0, right? Okay.
Yes, sir.
Okay. So what is V2 value? V2 value in terms of V1. V2 value in terms of V1. So can we find that anywhere?
Sir, in place
Sir.
of V1, write I2 plus V2, sir.
In place of V2?
V1, write I2 plus V2, sir.
No, this is already right. Only thing we need to find the V1 or V2 value, right?
Sir,
Yes?
sir, in previous slide, can you go, please?
Yeah.
Sir, if V1 substitute by I1 substitute by minus V1 and I2 substitute by 1 by 3 into dV2 by dt, and where 1 by 3 dV2 by dt is V1 plus half into dV1 by d2. Sorry, sir, same equation is here.
Same equation will come, right?
So first we can find the V2, sir. Then we can find V1, sir.
So
Easy.
first we can find V2 and we can find V1 now, sir.
So from this, what is V2? Tell me then. So then we'll go to that original one. What is V2 here? What you will get V2 here? So 2V1, okay, minus of, not minus, plus of
Plus 1 by 2 into dV1 by dt.
V1 by dt, right?
In place of V1, write I2
Okay.
plus.
So this is the V2, right?
Yes, sir.
So here, this is the equation for V2. So come to this equation. So V1 plus, what is the next term? 1 by 2 dV1 by dt plus 1 by 3 d by dt. In place of that, so we'll substitute dV1 plus of dV1 by dt. Agree? This is equal to 0. At last we found, right? So this is V1 plus 1 by 2 dV1 by dt plus this is 2 by 3 dV1 by dt plus 1 by 6 d square V1 by dt square. Is this correct?
Yes, sir.
So multiply this one with 6. So it will be d square V1 by dt square plus What else you will get? You multiply with 6. 6, this is 3, 4. Right. 6, 4.
7 dV1. You get 7.
6 plus 3, right? 6, 3 plus, yeah, 7 dV1 by dt. 4 plus 3. What is next?
6
So this is
V1.
3. 6 we are multiplying. 6 V1 equal to 0. So if you are confused, right? So how we are writing the differential equations, I just briefly explain. This is the circuit, right? So this is V1 and this is V2. This is 1 by 2 and this is 1 by 3. So this is 1 ohm and this is 1 ohm, right? This is the one, right? Okay. So now apply KVL at this one. So what you obtain at apply KVL and at this one. So V by 1 plus, so this entire thing is 1 by 2 into dV1 by dt plus V1 minus V2, which is equal to 0. Okay. So from this, we obtain the value of V2. So V2 equal to, so V, you have 1, this is V1. Okay. So 2V1 plus 1 by 2 dV1 by dt. Okay. Same thing, right? The same thing, we have written the same using the same KCL. So we can write this in another way. So V1 plus 1 by 2 dV1 by dt, right? And this current is known to you, right? So what is this current? If you know this voltage, so what is this current? So this current can be written as 1 by 3 into dV2 by dt equal to 0. Okay. So this is V1 plus 1 by 2 dV1 by dt plus 1 by 3. So this entire thing will come here. So dV1 plus 1 by 2 dV1 by dt, so which is equal to 0. Okay. So if we solve this one, so V1 plus 1 by 2 dV1 by dt plus 2 by 3 dV1 by dt plus 1 by 6 dV1 by dt, which is equal to 0.
1 by 6 d square V1 by dt square.
D square V1 by dt square. Yeah, right. So with this one, multiplying with 6, right, and adding all the terms, you will get d square V1 by dt plus 7 dV by dV1 by dt plus 6, right, equal to 0. Right. So that is the ultimate thing. So we obtained. So unnecessarily or not unnecessarily, so we are unable to get that logic, right? Same equation KVL at that V1 node, so we need to apply twice with 2 different ways. Okay. Okay. Anyway, after a lot of struggle, we obtained that equation. So now what is that characteristic equation? So it is s square plus 7s plus 6 equal to 0. And what are its roots here? Minus 1 and 6, minus 6.
Yes, sir.
Minus 1 and minus 6 are its roots, right? So what is its possible solution? A1 into e to the power of minus 1t plus a2 into e to the power of minus 6t. What is its value here? So this is the one, right? So what is the overall solution for V1 of t? What is the overall solution for V1 of t? So what is the overall solution for V1 of t? What is its steady state value? 20.
20, sir.
20. So we have 20 here, right? So what are the initial conditions? V1 of 0 and dV1 of 0 by dt. So what is V1 of 0? I think 0 volts, right?
Yes, sir.
So that means 20, that means A1 plus A2 equal to minus 20. So what is dV1 of 0 by dt? So that is what
40,
is its
sir.
value? Minus plus 40. So that means minus A1 minus 6A2, so which is equal to 40. So calculate A1 and A2. Calculate A1, A2.
A1 is minus 16.
minus 4.
What you say?
Minus 16 minus 4, sir.
Minus 16,
Minus
minus 1, 6 and minus 4.
yes.
Okay. So what is the overall solution? What is V1 of t? 20 plus minus 16. Okay. Minus 16 e to the power of minus t. Just check it out. A1 is minus 16 or is this correct?
Yes, sir. Yes.
Yes, sir.
So now we need to calculate V2 of t. So what is V2 of t? So V2 of t we are calculated, right? So V2 of t, this is the one. So 2 into V1 plus 1 by 2 into d V1 by dt. Okay. Similarly, what is V0 of t? V0 of t is V1 of t
V1 minus
minus V2 of t, right? That's all. So calculate this V2 of t. So what is V2 of t?
One minute, sir.
40 plus
40 plus
4 into e raised to minus 60
okay.
minus 24 into e raised to minus t.
This is the last one. So it will be minus 20. If this is correct, so it will be minus 20 minus 24 e to the power, no, they're different. Minus 20 minus 4 and plus 2. I think this is plus 20 into e to the power of minus t 60, and minus 20 into e to the power of minus 60. Just check it out. Just simple things. If you're done with this, just try to solve this one. This switch is open at t equal to 0. So find I of t and voltage across resistor VR. So VR of t. Also find voltage V of t. So I hope you understood this, right? So any questions?